So welcome everybody. I'm Paolo Baldan, the coordinator of the degrees in computer science here at the University of Padua. And I'm glad to be here today to present our master's degree. And this is kind of the program. I will be presenting in a succinct way objectives and structure of the master's program. And you will see that one key feature of our master program is that it is very much focused on innovation. And for this reason, I am very, very glad to have a special guest, Ruggero, who is the founder and president of the startup incubator M31, who will bring his authoritative and very expert view on innovation. And he will be speaking about information technology as a key enabler to innovation. And at the end of the presentation, we will have some time for your questions and we will try to answer. So, first of all, this is not the theme of today's presentation, but you probably know that we are also running an undergraduate degree. And computer science is quite a vast discipline. So the aim of the undergraduate degree is to give the very basics on a number of traditional subfields of the disciplines of computer architecture, operating systems, databases, networking, algorithms, programming, software engineering, along with the needed mathematical basis. So some calculus, some probability, numerical analysis, logic, and so on. At the end of your undergraduate degree, you have a bachelor and you can get a job. So why to continue, which is the aim of a master? Well, I would say that clearly the aim of a master is to go far beyond the basics. And in our view, this has to be done in two directions. On the one hand, deepening the foundations, because we strongly believe that a high-level professional in computer science should have an education which is deeply rooted into the foundation of the discipline. And on the other hand, differently from what happened in the bachelor, the idea is to widen the horizon by tackling advanced and innovative topics, which are often at the border and sometimes totally within the world of research. And I'd like to stress that the aim of our master's degree is not only, and actually not mainly, to give a bunch of new notions, to teach some new programming languages, some new architectures, some new notions, but rather to provide students with some advanced skills that we believe are essential for these students to work as innovators in a high-level technological company. And in our view, these skills are the capability of recognizing and classifying complex problems, the capability of identifying state-of-the-art solutions for these problems, and if there are no solutions in the literature, say, to develop new ones, to experiment with them, to understand which are better for which reasons, and so on. And also we believe that the high-level professional in computer science should not only act at the technological level, but should be able to contribute also to the strategic decisions of the company, of the entity he works in. And for this reason, you will see that we have some attention in providing courses which are not only, strictly speaking, in computer science. At the very general level, just to give you a very general overview, our master's degree is organized in three main study tracks, which are characterized by a wide spectrum offer and a long-term educational perspective. By this, I mean that there is a wide offer. You will see there are a lot of courses, and courses are not focused on the latest, on the details of the latest technological product, but rather they aim to provide you with the basic principles which allows you to keep up to date along your career. And the three study tracks are the following. The first one is in artificial intelligence. The second one is in internet, mobile, and security. And the third one is on programming languages and systems. I will later get to you more details about the courses and the organization and so on. But before that, I'd like to stress that a footprint that a main aspect of our master's degree is a special focus on innovation, on informatics-driven innovation, which, as I mentioned before, is not only seen from the technological point of view, but rather from different perspectives. And we believe that an important point of view is the economic, management, and entrepreneurship aspects. And you will find instances of this in various ways in the study path. There are courses. For instance, there is a mandatory course in economics and management of innovation. And then there are some elective courses. One of them is, for instance, startups in ICT, which is taught, by the way, by a collaborator of Ruggero, so Fabio D'Alessi from M31, where you learn how to transform brilliant ideas into working and effective and successful companies. And then we also like to offer students the possibility to interact in different ways with advanced technology companies, which are sort of partners of our master's degree, mainly incubators and accelerators. Here is a partial list of them. And this interaction happens in different ways. During the studies, we offer a startup lab, which is a sort of crash course, introductory course to the world of startups. Then there is a series of seminars, which is called ICT Challenges for Startups, where we ask companies to come and present them to students to say what they're doing, which are the challenges they're facing, which are the exciting projects they're working on. And this can be important for the master course as a whole to get stimuli, can be important for students to be oriented in their study path. And also getting in contact with these companies can be important for students because there is the possibility later on at the end of your study path to realize the master project as a sort of internship in one of the companies. And this is kind of a general overview, and you see that innovation is kind of a key word. Innovation and focus on the interactions with companies that make of innovation their mission, their reason of existence. And I think this is really the right moment to give the stage to Ruggero Frezza, which, as I mentioned before, is the founder and president of M31, which is a very active and very successful startup incubator. He has very close connection with the University of Padua. He got his degree at the University of Padua. Then he moved to the University of California for a PhD. And he came back as a professor of electrical engineering. And at some point, he started his journey in the galaxy of innovation and founding M31. And since then, M31 has become a quite successful startup incubator, which is active at national and international level. So I'm very glad to have him here. We are very lucky to have Ruggero here, who can bring his view on the theme of innovation and information technology. Thanks a lot, Ruggero. So please.
Thank you very much, Paolo, for your introduction. Thank you for the invitation. It's very exciting to be here because there is so much need of people with expertise, of the knowledge and the know-how that you described before. I remember maybe 10 times ago, people were skeptical about the continuation of the Moore's law, but in reality, as you can see from the slide, it's continuing to be valid. You know that the Moore's law states that every 2 years, the number of transistors in a chip double in the same area. And we are gotten to the point that where etching a chip now is down to a few nanometers. So it's really incredible that it continues to be valid, which means that, of course, the computational power, the energy required for the same amount of flops decreases. But what is interesting also is that in these years, the Moore's law appears to be valid also for connectivity, for example, for the bandwidth of wireless communication. This is a semi-log plot of the bandwidth of Wi-Fi in the past years, which I just got from the Wi-Fi Now global site. And what else is happening? That there is this concept of ever-expanded interconnectivity, the API economy. So everybody is building on the foundations of what we ever did, or what we ever developed. I invite you to read this nice blog by Augusto Marietti, an Italian young guy who founded a very successful company in the United States, Kong, which is an API commerce market. So all of these three aspects, the Moore's law applied to the computer, to the CPU, the Moore's law applied to the wireless connectivity, the ever-expanding interconnectivity lead to the realization of what Mark Andreessen 10 years ago said. Software is eating the world. He said that 10 years ago. So who doesn't know who Mark Andreessen is? Mark Andreessen is the founder of Netscape, and now one of the most successful venture capitalists of Silicon Valley. If you want, you can go and check his blog, a16z.com, where you can find the article, Why Software is Eating the World, but it's really interesting to read it, to understand where the world is going in terms of ICT, and where the investors are putting their money. So where the innovation is. Well, the software is really eating the world. So I just put this picture because probably you know already that 40% of the cost of a car today is represented by electronics and software. A car today is the most complex engineered, manufactured item in the world. It contains millions of lines of codes. It's more complicated than a rocket for space. I mean, it's really quite amazing. But it's not only cars that are there. I put a picture of a product that we interpret as probably a simple, low-cost product, you know, a stove to heat the house, a wood stove. Well, even a wood stove nowadays, it contains tens of thousands of codes, because the stove needs to be interfaced to a smartphone, to the cloud. It has to be integrated with HomeKits from Apple, with voice-activated devices and stuff like that. This requires into the stove the deployment of a high complexity system in terms of management of the services that this product can offer. So this leads really to a fantastic and beautiful and very exciting scenario today, which I titled the digital twin, the software augmented reality. When I talk about software augmented reality, I really do not refer to augmented reality as people perceive it, you know, just through a screen with added information, augmented information of what you see. To me, augmented reality is what we saw before. A wood stove, a car, software augmented. This is the era of software augmented products and digital twins that represent digitally the product in order to be able to control and understand and predict what the product and behavior will be. So let me show you real quickly what this can lead to with a demonstration of what we can achieve today. Okay, the reason why I chose this video are many. First of all, because this product, this car simulator, is one of the most complex products that you can imagine developing with the use of ICT technology. It is a very successful, second reason I wanted to show you this video is that this is a very, very successful startup, which is based in Udine, close by. And it's actually collaborates very, very strictly and strongly with the University of Padua. All the control algorithms, the ICT, that the software that are implemented in those simulators are in a major part developed here with a collaboration with the University of Padua. Now, the reason also, the third reason why I'm showing this to you is that these products completely disrupted the automotive industry in the sense that allowed the automotive industry to shorten the time to market of new new models of cars from 4 years to less than 1 year, because they don't have to develop anymore prototypes. They use the simulators to test the new vehicles. Now, if you think of the complexity of a product like that, it is really mind-boggling because you have to simulate the dynamics of a car, you have to simulate the environment in 3D, down to the level of simulating the friction between the tires and the road. So they do, for example, one thing they do is to acquire the granularity of the asphalt on the road in terms to be able to model the interaction between the tire and the road correctly. They model the audio, the noises that you can hear, because you have the human in the loop. You have the pilot in there, and you have to trick the perception of the pilot with a simulated environment so that the pilot feels as if he was driving the real car. And this is a startup that was born in 2005, and now it's owned by a multinational company based in UK called Spectris. And I'm very happy to tell you that, for example, even if it's an Italian-based startup, you recently bought, and people don't think that these things can happen close by. In reality, this startup just bought a few months ago Concurrent, an important company, US company developing a real-time operating system for a very important amount of money, and now owns Concurrent. And the most advanced simulating part for automotive industry is actually based in Udine. It's not far from here. Sorry. So this leads me to another fantastic and beautiful area that is very, very hot today in terms of innovation, real-time concurrent systems. Why is it so important? Because, as I was saying before, it is the era of digital twins. The next step after the simulator that we saw is to bring the dynamics of the vehicles and into the car. A real digital twin running in parallel into the car. Maybe you're already aware that, for example, Tesla is always running the autonomous driving mode. Even when you drive the car, it has a shadow mode which keeps going in order to learn from what you're doing and actually maybe monitoring that you're not doing things that are completely wrong and avoid accident. So there is always a digital twin, a digital version of a car, a digital model of a car running in parallel with the physical model of a car. But the point here is that even in a simulator like the one that you saw before, you're not really interacting with real systems. You're simulating the system. So what is exciting here to me is that you have to ask yourself, what does real time mean? What is real time, right? And if you ever used this simulation, Simulink or MATLAB or simulation engines that nowadays are becoming tools for the design and validation of complex systems like cars in a framework that is called model-based design, you probably experienced the problem of algebraic loops. So when you close a feedback loop, a control feedback loop, without having a low-pass system inside the loop. So when you have a problem detecting what is the cause and what is the effect, because you're feedbacking the effect to the cause, and there is no low-pass systems in there. This brings also to interesting philosophical questions between the clash between cause and effect. But the level at which ICT is nowadays brings you to philosophical questions, like, for example, the big question of the singularity. What is the singularity? Is the singularity simply the fact that computers are gonna reach the computational, the analytical capacity of a human brain, or is it more complex than that? Or what does that mean anyhow? So it's a fantastic moment, I think, in this incredibly powerful area of ICT, where we are reaching the level of the boundary between science and philosophy. It's the third fantastic, what is ICT used for? Mainly to manage complexity by automation, actually by hyper-automation, right? If I have to manage a very complex system, I have to leave the ICT system to manage some subsystems, like it happens in the cars today on any other system. But as a good example of what this means is this. Think about what happens when you click the one-click buy button on Amazon. I mean, you trigger a number of incredible events that have to do with payment, access to your bank account, have to do with machine learning, profiling you. Oh, look, this guy bought this, maybe the other month he bought this other, correlations and stuff like that. It comes from Padova, so everybody in Padova buys this. That's interesting, lots of machine learning, lots of interesting data, and also automation, robotics. Your one-click order goes into the warehouse, the nearest warehouse that has the item that you ordered, and a lot of robots start collecting the item, delivering it to the packaging units and to the delivering units. Well, once again, this seems far away, but it's not far away. And the reason why it's not far away is, let me give you some small informations. Kiva System, the company that you see on those robots, there is written Kiva System. Kiva System is another startup that was founded by an Italian guy called Raffaello D'Andrea. He's now a professor in ETH in Zurich. But if you go into raffaello.name website, you will find his personal website, and you'll probably find in there the history of Kiva System that was bought by Amazon and became Amazon Robotics, which powers all the automation of the logistics of the warehouses of Amazon. So one-click button means the management of an incredibly complex supply chain that will deliver your what you bought to your door in less than a day. This is quite amazing, and this is all ICT, of course. It's all software and robotics and automation. There is another issue that I find extremely interesting, the fact that the world is becoming interconnected, and that wireless connectivity is achieving incredible results, of course, means that the perimeters of interactions with products and objects and people are extended to to the whole world. And so the question is, what's happening today in terms of innovation? If you think about that, think about this concept of extending the perimeters of interaction with an object, with a product, right? If you don't have ICT inside, if you don't have software augmented product, you can interact only at the length of your arm. You have to click the on button. If you implement IoT or whatever, then you immediately extend the perimeters of interaction with that product to anywhere. And today, if you think about it, sustainability and the big trends of innovations are linked to what? To information and to electrification. Why is electrification? Because it's the form of energy that can be transported, right? Can be moved without moving mass, because you can transport it on power lines. But electricity as data do have inertia and gravity. Even if it's much smaller than mass, having to deal with the data that is on the cloud and not in the edge, not in the field close to you, it means cost and latency. It means introducing delays, latency, and costs. And the interaction levels, like the one that we saw in the simulator before, require very, very low latency. If you start having a latency of milliseconds, you perceive that the world is not real and you cannot interact properly with your products. So there is an issue here that is extremely interesting between edge and cloud solution. Where should you put your complex ICT systems? Where you should run your machine learning or AI application, on the edge or in the cloud? There are certainly terms, there are issues of cybersecurity as well, but the main issue, in my opinion, is the fact that you have data gravity, the inertia of data. Data are like physical objects. They do have a concept of gravity applies to data as well. This, in terms of ICT solutions today, has an incredible implication in the architecture of your complex ICT systems. And that is why, for example, edge is becoming so important. Even in the big cloud providers like Amazon Web Services, for example, nowadays offer the possibility to replicate at the edge level what the services that they offer at the cloud level. If you go and check on their website, you will find it. And then I stole this slide from the movie, the presentation movie of your master degree, of the Laurea Magistrale, because of course, there is an important concept behind this slide. ICT is extremely powerful, whatever, but it always represents tools, and it brings innovation opportunities to a number of different sectors. But it's really, they are tools that need to be applied to different sectors, right? So this is really interesting because it happens to us, for example, when we try to hire a computer scientist, it is so important to have a curiosity, interest, and develop and study and the basic math, physics, and things like that, because they're extremely important. You need to deal with them in order to be able to apply the ICT tools at best. So I wanted to close this presentation quickly with some examples of what happened close by in some of these sectors, like, for example, healthcare. This is an image of a retina taken by a device developed by a local company, which was actually a startup born in M31 called Centerview, nowadays called iCare. It's still in Padova, but it's part of a Finnish group, a group of company based in Finland. And let me just tell you the valuation in the stock market of this Finnish group. Today, this group is valued 1.6 billion euro. And it's really based in Padova. It's a spin-off of the University of Padova. And why it's evaluated so much money? Why its value is so high? Because they have the best imaging devices of the retina in the world. So they introduced a very powerful innovation. They allowed doctors to see what they couldn't see before. Thanks to what? To ICT technologies. Not only, but really deep ICT technologies, hard ICT technologies, imaging, for example, super resolution imaging and stuff like that. There is another area that here in Padova is very, very important. And I took it as an example because this is a revolution in medicine, in healthcare. This is an artificial pancreas system. It's the best therapy, it's recognized nowadays as the best therapy for a diabetic patient of type 1 diabetic patient. Type 1 diabetic patients are the ones that do not have, they cannot produce insulin anymore autonomously, so they have a problem of regulating the glycemic level in the blood. Why is it an important trend in ICT and innovation? Well, because some companies were able to introduce the enabling technologies, which is the continuous glucose sensor. It's a small wearable device that you can put on your body, usually in the arm, not on your belly, but like that, but in your arm, which can measures continuously the level of glucose in your blood, and sends these measurements every 5 minutes to a pump, which is also connected through a needle to your body, and injects insulin, infuses insulin in real time. So this is the example of a real-time pharma dosing, automatic pharma delivery, which is called artificial pancreas because it does what the pancreas should do and is not able to do anymore, and becomes the best therapy for diabetes ever. So the result of this is that many of these patients do not experience anymore the terrible consequences of diabetes, like amputations of feet or blindness or stuff like that, because they're able to keep into the proper range their glucose for more than 80% of the time. And if you want, in the University of Padova, there is the team that introduced this technology first, maybe 30 years ago. But now this technology is getting applied, is now becoming available because, of course, in the biomedical sector, you have to go through certification procedures and stuff like that. This is another incredible example of ICT-based innovation, because here you have everything. You have real-time systems, Bluetooth connectivity, wearable systems, cloud solutions, because all the data of the patients go into the cloud and they're available to the doctors to monitor how the patient goes on and to properly tune the system for the patient. I tried this on myself, actually. I put myself for a few weeks a glucose sensor, and this is the typical data that you get. And it's interesting. Why is it interesting? Because this gives you awareness of yourself. It's self-awareness. You never know what your blood glucose level is, right? But if you put one of these sensors on, and this is a screenshot of the app, this is what I can see. This is, you see the probability distribution of my blood glucose sensor during the day. The median is the black one, and the other ones are the percentile, probability distribution based on percentile. And this is finding new applications. There is another startup company in California called Super Sapiens. Of course, it's founded by an Italian guy. It's true. Called Super Sapiens, which is applying these glucose sensors. It's this white dot that you see here on the arm. to monitor high-performance athletes, to monitor the metabolism of high-performance athletes. But this, of course, finds a number of potential applications. This is going to be a revolution in the healthcare sector. The possibility of monitoring important quantities like of metabolism signals, like the glucose level, continuously for months, right? Even if you're not a patient affected by diabetes, it could be extremely important to do that. And not only for athletes, but also for people like me or anybody else. So what is the conclusion of this? It's exponential seems to be the keyword of computer science, right? Yeah, exponential. The Moore's law is exponential. The interconnectivity of the API economy brings to exponential speed in the production of new software solutions. So I asked myself, but the exponential keyword applies also to innovation. So is there a Moore's law also for innovation? So in order to try that, I checked and I looked at the number of startup companies in the years in ICT. And look at this, the graph is exponential, right? And then I asked myself, but what does this really mean? Startup companies are nowadays the laboratory of innovation. It's where innovation gets tested. So larger corporates buy startups to generate innovation. So if you see the number of startup companies is increasing exponentially, but what about acquisitions? And if I looked at the acquisition only in the AI sector, which is one of the columns of your laurea magistrale, and here you go, it's exponential as well, right? So really, exponential is the keyword of ICT. Exponential is the keyword of innovation. This is, I mean, you should be, 400 people should be connected to this laurea magistrale presentation, because we need computer scientists badly. The world needs computer scientists. Thank you very much. I think I should stop here.
Thanks a lot, Ruggero. This was really inspiring. So let me come back to some hopefully useful, maybe less exciting details about our master's degree. First of all, some words about the entry requirements. You can find full information on the websites that I will mention, but okay, some few words, general few words. To enroll our master's degree, as any master degree in Italy, you need a bachelor or an equivalent title, which is providing some reasonable background on the basics of computer science that I mentioned before. So computer architectures, operating systems, networking, databases, algorithms, programming, maybe not all of them, but a large part of this. And also you need some decent mathematical basis. This is very important for a master. What does it mean concretely? Well, to enroll the master in computer science, for sure, a bachelor in computer science or in computer engineering would be fine, but also a bachelor in a different discipline, for instance, mathematics or in statistics or in physics could also be fine, but then you have to prove some skills in computer science. Concretely, okay, this depends. And for Italian students, there are some rules. For non-Italians, the rules are slightly different. So I invite you to check the precise rules. I will mention later some websites where you can find information. And since the courses are given in English, you also need to prove some basic level of English, which is B2 level listening and reading. For further informations, these are the applications and informations about application and deadlines, which unfortunately are different for Italian and non-Italian students. It is a bit complex, but Italian students must apply something that in Italian is called pre-immatricolazione, starting from July 17 until September 30. And this is all the process is done through the site uniweb.unipt.it, where you can also find information about the rules, the conditions for admissions and so on. And for non-Italian students, there are different deadlines, and you can find all the information and at this site, apply.unipt.it, and this is the site through which the process also can be performed. So, few more words and few more details about the structure of the program. Something a little bit boring, but I need to say this to give you some ideas. To get your master degree, you need to get 120 credits in 2 years. You know that the credit is a kind of a canonical, conventional measure of your effort, study effort. So large part of this effort, 65%, which means 78 credits, goes to courses. Since the typical size of courses is 6 credits, this means 13 courses, of which large part are in computer science, 55 credits, which means 9 courses. Then you have also to take 2 courses which are not in computer science, but in related fields. These are fields which are either useful for computer science or where computer science finds applications. So economics, mathematics, biology, information theory, signal theory could be some examples. And finally, you have 12 credits, 2 courses which are in totally free elective courses. Typically, these are used by students to take some courses from other master's degrees. Then 6 credits goes for other activities. This can be seminars, short internships, and so on. 3 credits are for improving your English language from B2 listening, reading, which is the entry requirement, to B2 writing, speaking. If you already know enough English, you don't need to take any exam, just bring your certificate. And finally, a quite important part in the master degree is the master project that you see is 33 credits. So essentially 1/4 of your effort, which means 1 semester full work, which allows you to realize an important piece of work, a quite deep and wide work. I will come back later to this. How do you build a study plan? This is kind of peculiar of our master's degree also. Some master's degree have quite rigid study paths. In our case, we find it important to offer students the opportunity to build a highly customized study plan by choosing with a large degree of freedom among a wide offer of course units. So you are very free in building the study plan, but to help students to build a sensible plan, there is some structure which I try to outline shortly. There are only 3 mandatory courses. 2 are in computer science. The first one is computability, which is essential about the foundations of the theory of computation. Roughly, it tries to answer the question, what are the problems that a computer can solve? So what are the problems that can be solved algorithmically? Then there is a course on advanced algorithms. It is about algorithms on graphs, strings, parallel algorithms, randomized algorithms. And you know that algorithms are really at the core of any advanced topics in computer science. And the last mandatory course is not in computer science, but in economics. It is in economics and management of innovation. It is taught by a professor in economics. And there are different talks, different cooperations with people from startups, incubator, and company experts. The rest of the courses you have to choose. So you have to choose 7 additional courses in computer science. And to add the choice, we organized courses in majors and minors. Majors are groups of 5 courses that deepen some thematic area, while minors are groups of 2 courses, so smaller groups, which has a specific focus. We have 3 majors that I mentioned before. The first one is in artificial intelligence, with a basic course in artificial intelligence, so an introductory course. Then a couple of courses devoted to learning, machine learning, and one which is devoted to probably the most popular technique, successful technique by now, which is deep learning. Then a course in knowledge and representation and learning. And finally, a course about the applications of artificial intelligence in different fields to what are normally referred to as cognitive systems. Most of these systems are those that Ruggero mentioned before in his presentation. And here, a particular emphasis goes to applications in vision. A second major is on internet, mobile, and security, where the emphasis is on the realization of the development of large-scale application. And here we have courses about networks. So for instance, wireless networks for mobile applications, mobile programming and multimedia. Then a course which is devoted to the management of information on the web. All these applications must be supported by suitable infrastructure. Ruggero was mentioning cloud and edge computing. So you have a course which is devoted to this, which is runtime for concurrency and distribution. And then clearly in all these settings, security plays a role. So you will be touching upon this subject in all the courses, but there is this course which is specifically devoted to this, which is computer and network security. And the last major is on programming languages and systems. Here the focus is on programming languages and on techniques for assessing the correctness of software. So you have several courses about programming, advanced topics in programming languages, functional languages, languages for concurrency and distribution, and a course which is devoted to software verification. Here the point is to present techniques for the verification of the correctness of software. And you know, for instance, that testing is a nice technique which allows you to gain some confidence about the correctness of a piece of software, but if correctness is really critical and you want to be 100% sure, then you need some formal, rigorous techniques to verify the software. And this is the content of this course. And then the last course is on a similar topic, but applied to software systems which interact through sensors and stuff like that with the outer world, with the physical world. And these are what are normally called cyber-physical systems. Then you have three minors. The first one is on Internet of Things and embedded systems, with courses on mobile and IoT security and real-time kernels and systems. The second minor is about the management of large quantities of data. So you have data and process management with courses on process mining and big data computing. And the last minor is on economic and management teams. So it is innovation and entrepreneurship in ICT with courses in ICT service management and startups in ICT. Then you have many other elective courses. You have to take two courses in a group of courses which are not specifically in computer science, but in related fields. I won't go through the list. I just mentioned that all these courses are somehow related to the major and minors, which I mentioned before. For instance, if you're interested in security, then you will likely take as an elective course cryptography, or if you're interested in programming languages, type theory could be an elective course for you. What are the rules for the study plan approval? So how do you get your study plan approved? Well, this is very simple. Rules are quite flexible, and essentially to get your study plan approved, you choose your courses and you have to follow a major, which means that your study plan must contain at least 4 courses from a major, and all the remaining courses you can choose free. And if this doesn't fit your needs, if you like to build a different study plan, you can. You are encouraged to do this. You can build your plan and then submit it to the mentoring commission. And if you have good motivation and you have a cultural design in mind, then your study plan will be likely approved. Something Some more about the master project, which is an important part of your study path, kind of apex, the end. As I mentioned before, it is quite a relevant part of your effort, 33 credits, which is 1 semester full-time work, which allows you to realize a significant work on research and innovation problems in computer science. For instance, under the guidance of a supervisor, you can develop some original piece of research or some innovative software product. And this was already mentioned. You can realize this, in some cases, as an internship, an extended internship in one of the partner organizations for different aims, for cooperating in the development of an innovative project, for working on new products, and possibly, clearly, this is not the standard, but you can start thinking of designing your own startup, and you have support for this. Finally, some words about research and career opportunities. The master course, being focused on innovation, it is very much research-centered. So professors teaching at master level are quite active in research. They are active in national and international projects, which means that most course units will be research-centered, and in essentially all courses, you will have the opportunity to get in contact with research teams. But the moment in which you really do some serious piece of research is your master project. Well, depending on your attitude and on your preferences, you will be doing some theoretical or applied research, possibly in a company. In courses, but especially for the master project, you will have access to labs. There are standard labs, but also some special labs with mobile devices, sensors, and drones for some special courses. And if you're doing some computationally heavy, intensive activity, you can get access to a powerful cluster and to virtualization facilities and so on. And if you really like research, then it's probably nice for you to know that the master degree, both formally but also in practice, will give you a preparation which allows you to access essentially any PhD program around the world. And I'd like to mention that we have also a PhD program here in Padua, which is quite innovative. It is called Brain, Mind, and Computer Science, and it is in cooperation with the neuropsychology department. Concerning your career, finding a job, well, you probably know that the market is really hungry, waiting eagerly about new computer science professionals. So computer science professionals are in extremely high demand. So your problem won't be to find a job that you like, but rather I can make some joke to avoid to find it too early before graduating, because this could be an obstacle to reaching the end of your graduation properly. The possibilities are quite a lot. You have a wide range of opportunities. I won't go through this list. Let me just conclude with some numbers about our master's degree, which are taken from these statistics which are done by Alma Laurea. The unemployment rate is essentially 0. Everybody finds a job. And what kind of job do you find? Well, depending on the years after the graduation, from 92% to 100% are working in computer science, so working for that they've been studying for. And according to the student judgment, what they learned is, for 100% of them, we're really proud of this, is useful for their work, either very useful or useful. But okay, nobody says it was not useful at all. And okay, money is not everything, but you can also observe an increase, which is around 25% between undergraduate and graduate students. So, okay, this is essentially all I wanted to say. Thanks a lot for your attention, and you will find much more information on different websites. There was the one which I mentioned before, but also we have a website for the master degree. Here is the link. The slides will be made available later. Thanks a lot for your attention.